Okay, welcome everyone to this week's colloquium. We have a very distinguished speaker, Dr. Randy Simpson, and I'm just going to give you a brief bio of him. You can read his longer bio online, but basically, he has a set of degrees from the Ohio State University. I went to Michigan, so I won't hold that against you. The Georgia Washington University, the Virginia Polytechnical Institute, and State University. And his entire career has been a combination, many different places in academia, government organizations, and industry. So currently, he is a member of the Institute of Defense Analysis, and that's basically managing and executing studies and analysis that are directed by the Department of Defense. So it's very much defense-related type work that has been prevalent throughout his entire career. The emphasis of his work during the last decade has really been information security, which, as many of you know, not only in the government side but also on the private side, information security is becoming an enormous issue of importance. And of course, it's very prevalent here at UW in terms of research. His current project is working for the Secretary of the Air Force Office and the Next Generation Information Assurance Architecture for the Air Force. And so with that, I will let Dr. Simpson take it away. Okay?
Thank you all for coming. Afternoon meeting, a dull, dry subject. I'll try and keep it from being too dry. What I'm going to talk to you about is the next evolution. This is the fourth or the fifth by my count of the IT systems for the U.S. Air Force, which is evolving into an IT system for the DoD at some point downstream here. Let me just give you the disclaimer at the bottom here. Although I work for the Secretary of the Air Force, the Secretary will disavow any knowledge of any member of my team that's caught or killed during this mission. If you have to attribute something I said here, attribute it to me. Don't attribute it to Department of Defense, to the Secretary of the Air Force, or to IDA. Okay, now that we've got that out of the way, let me show you where I've come from on a fourth or fifth generation representation. This is my chart. This is not in any official DoD representation. But if we go back probably before most of you in this room handled computing, you'll see we have this disconnected evolution at the top of that screen. Office computing, the office computing evolved into departmental computing. Departmental computing went to project and functional computing, and so forth. Those are all what I call the disconnected phases. We didn't have wide-scale connectivity between computers at that time. And when we put computer systems together to serve many people, we usually did it with mainframes and put them in some special enclave where a bunch of us geeks ran around and maintained the enclave. That evolved into the first set of connected computers, and that's that first evolution you see there that I've got in the first box. And that was made up of a collection of connected representations. Now, for the Air Force, one of those representations was a major command, what I call MAJCOM there. So each major command, like the Air Mobility Command, for example, would put their computing systems together. They would wind up with some kind of connectivity to the other commands, and they'd wind up with some kind of security paradigm that would say how those guys would communicate across those various things. Often those security paradigms were completely different from one another, completely different strengths, etc. The next evolution was to, and of course on one side of that was a NIPRNet, which was available to everybody, and we put the small utility functions out on the NIPRNet. The next evolution was to expand the NIPRNet, and the NIPRNet was, for the Air Force, was called AFNet Ops, Air Force Net Ops. I use a lot of acronyms here, so somebody raise your hand if I see an acronym or I say an acronym that you don't know. I'll try and spell it out for you. And that was a more general expansion. We got rid of the MAJCOM structure. We went to a single type force type thing, and everybody in the Air Force could access those particular applications if they had access authority. And that was a big difference because each individual application determined what the access authority, the identity authority was to do that. Moving on from there, we moved on to our first iteration. You'll see here we've got Type 2 forest, Type 1 forest, NIPRNet, AFNet forest, and Internet. Now I call that the basic mud room, clean room, and Wild Wild West. The Wild Wild West refers to the World Wide Web, of course. In the Wild Wild West, there's probably no security paradigm. Today, some particular aspects of the Wild Wild West are working on security paradigms, but nobody has it straight yet. The next box, the one in gray, is where we're at today. I'm going to talk about the Type 1 NIPRNet trusted forest. These are the other adjuncts that go with it. So we still have the mud room, which is the Type 2 NIPRNet. Those are the guys that haven't gotten their security straight yet. We have to interface with them. And all the way out to the Wild Wild West on the other side. And then on the back end of that, we've got the classified networks. NIPRNet feeds to CIPRNet, feeds to JWICs. And there's a number of cross-domain paradigms that go in here at this particular point. So this is the current state. I'm going to talk just about that Type 1 forest. That's the high assurance forest that we're talking about here. In the high assurance forest, I know and vet all of my users. The next evolution, I don't know, I got a question mark on here. They're talking about multi-level security, one multi-level security to encompass all of the particular domains that we do in classified. And two different types of forests before you get to the internet. Just how many of you in this room are computer science students? Wow. What's everybody else? Electrical engineering? Okay. How many of you guys in electrical engineering know anything about computer science? Oh, okay. Well, that's good. That's good. I'm glad you're keeping up. Okay. So this is called the OSI stack. This is an operations service interface stack that we use for describing the various levels of communication that go on in a particular system. As we move up through this, we got the machine layers on moving up to the TLS, SSL layers. Most of those are dominated by commercial products as we go through here. And those things over the years have been tightened and hardened, and they're doing pretty good. So there's still a few holes in them, but they're doing pretty good. Most of the attacks that we get today are coming from these upper layers at the application and above. And that's because these lower layers are getting hardened and the applications are subject to various things, including social engineering, as we go through here. One of the things I want you to see is that in an untrusted network in between a trusted service invoker and a service provider, you'll see we fall a little short of actually securing the endpoint of the communication. So a user goes to invoke an application, and at these lower levels, we stop at the server. We don't go to the service itself. So one of the things we want to do is kind of move that up to the server thing. So when we're trying to look at this next generation thing, we had to look at the old generation and see what was wrong with it. Many of you have probably read in the news that the Chinese are reading our email, and you probably know that that's not good from the standpoint of the Air Force. They're not only reading our email, they're reading our databases, they're picking up all this information as we go through. So the old system's not working. The old system was built like a medieval castle. The outside of that castle was built with very thick walls. And as we learned new things, we put barbed wire on top of the walls, and we maybe electrified the fence. But because of the complexity of the system, they still figured out ways to tunnel in. They went down underneath, they broke through the castle door, they went over the top, they managed to get in. And the only trouble with the castle mentality is that we didn't put any security inside. So once somebody got in the door, he had free reign inside. Now, it was okay when we were back at those early stages where everybody had their own little enclave, and if a compromise happened, it happened within that enclave. But as we spool up now, and we're going to bring everybody into one set of computer services, we can't afford to be soft in the middle. So that's the basic structure we've got to look against about how to tighten this thing up. So we started with a very simple concept. The very simple concept says we're going to distribute this security throughout the system here, and it's going to begin with know your partner. So I've got an entity A, might be a person. By the way, when I talk entity here, it can be a person, a machine, or a service. And when I talk active entity, it's going to be a person, machine, or service that acts on information. A passive entity will be one of those that doesn't act on information but may transmit information. Some examples of that might be load balancing, or distributors, as we go through here, might be passive. So we've got an active entity A and an active entity B, and one of the things I want to make sure is that A knows B and B knows A. Very simple concept. They get pretty complicated when I get further downstream here, but that's a very simple concept to start with. And that's the know your partner. And then the other thing is the privilege is determined by the provider or the information owner. So as we go through this system, I have the Air Mobility Command that keeps track of where the C-17s are and how much capacity they have available to move troops and things like that. The owner of that data is the one that determines privilege. So he says who has access to it and who has privilege to it. And we're going to have to actually provide some kind of representation of ourselves that says I have claim to that data. Another simple concept, right? And claims are built for both of those, and I'll talk about those a little bit later. And the authorization part of it is built into two pieces. One is access, do I even want to talk to you? And the other is if I deem myself wanting to talk to you, then the question is what kind of privilege do you have once you get to me? So those are the two aspects of authorization. So when we talk about knowing your partner in this communication, we're talking about authentication. It's a long way of saying identity, right? In this particular case, authentication means identity in some secure fashion. And when we talk about access and privilege, we're talking about authorization. Typical web services setup, we're moving towards web services now because there's a number of commercial standards and paradigms that allow us to invoke full standards-based security based on web service paradigms. So basically what you see here is a user at a browser or a presentation system. The only thing that makes that user different than any other active entity is, does everybody know? Users speak HTML. Okay, most other services talking to other services talk XML. Why do users talk HTML? Because that's how the browser renders the presentation to the screen for you. So those of you that use a browser regularly, you realize that you're going to pages, you're getting pages from the web, and they are written in HTML, and all of the factors that go with HTML. The browser renders what you see on your computer screen. So the paradigm is I want that user at the browser to go out and invoke a web application of some kind. That web application may invoke other services downstream. What you see here is I've got a pipeline that says I'm going to secure that confidentially. I'm going to do an authentication between two of the communicators on this particular thing here. And we may chain that all the way downstream in a web service paradigm. So we may call services downstream, and those services may call services downstream. There's one thing on here I haven't talked about yet, and that's the STS. The STS is a security token server, and that's going to provide one of my credentials as we go through here, and I'll talk a little bit more about that as we go through. Okay, the basis of the Air Force computing operations was that, number one, it had to be extensible to DHS and other government partners, so we kind of got a leg up on the DoD-wide one at this point. It also had to be extensible to coalition partners. That's the Afghan security forces. You guys know how secure they are, right? So we have to take those guys into account. And it can be adapted to this joint information environment for DoD-wide application. As we began to put this together, now I don't want you to think this all happened up front because we're not smart enough to do this up front, but as it evolved, we developed these basic tenets. Now, normally when you put together security on a system, you attack the thing at the top there called CIA, right? With this confidentiality, integrity, and availability. You quickly learn when you're talking to the customer that hardly anybody does them in that order. In fact, if you ask a 4-star general what his number one concern is, it's availability. If you ask him what his number 2 concern is, he'll say integrity. Number 3 is, I don't want the Chinese to read what's going on. So it's really the other way around, AIC, okay? That also is true for most of the commercial users that you want to see. Availability is first. Integrity means, can I rely on the information first I want to get the information. Second one is, can I rely on that information? And the third one is, I might want to be able to do this in confidence. Your bank accounts, for example. They care that the transaction goes through, they don't care who reads it. So your deposits and withdrawals, while they might happen for the bank, they may be on your Facebook page next week. If Facebook can figure out how to get that information from Google, who has to give it to the NSA, okay? You guys are supposed to laugh in here at some point, so just pass that along. Okay, so these tenets are actually the basis against which we hold all our designs. So we have to actually walk through these tenets and say, yes, have we accomplished that, or no, did we violate it? The first one is that the bad guy's there already. It's been demonstrated over and over again that this fortress mentality is not keeping him out. We got guys working around the clock looking for chinks in the armor, and the complexity of the system is so great that we just can't do a 100% test. And so the guy comes in and he gets in there, and we get some indications he's in there, and we send a forensics team and we clean him out, and 2 days later he's back again a different route. So he's there. We got to be able to work against it. The second tenet is it has to be simple. It has to be simple because I got 700,000 people in the Air Force that have to use this, and most of my 700,000 people that have to use this haven't got the foggiest idea about how IT works and what's to be done. The second tenet, and closely related to that, is extensibility. Whatever I do here has to be able to extend to Federation partners. It has to be able to extend to other people that want to use the system. It has to be able to extend to our classified networks and so forth. I'm not going to talk about the classified networks as we go through here, but basically they're formulated the same way. The third tenet is information hiding. Most of you that write software know about information hiding, right? Don't provide any information that's not needed at any given time. That also goes true when the police pull you over on the side of the road. Just answer the questions. Don't add any information as you go through. You want to do information hiding. The fourth one, and that's the one that's hard for most people to understand, is accountability. When actions are taken in an IT system, we have to have a way to hold accountable the individual that, or the entity that actually took that action underway. So accountability is a big one. It's a hard one to get, and it entails a lot of stuff that goes with it. The next one is minimum detail. I'm stuck with that one because of procurement policies. So what I have to do is I have to specify the actual minimal detail to accomplish this so that I can write a procurement document and not exclude anybody. Everybody has to be able to jump into the bid and say, I can do it, and we have to do an evaluation to see if they can. And of course, that kind of process gave you Obamacare. The next one is it has to be service-driven rather than product-driven. So again, that's a procurement issue. I need to abstract the functionality that I need as I go through here, and I need to ask for that function and not for specific products that do certain things. That's not often easy to do, by the way. We have to maintain lines of authority. That's my 4-star generals made me put that one in there. When a decision is made, it has to be made at the appropriate line of authority. So most of our decisions are hard, and if somebody is willing to jump in and make a decision, it stops there. If he thinks it's too hard, he bumps it up the line, so the next guy up the line gets it. So if I wanted to give away the airspace over Moscow to the Israelis, that would probably happen at the Secretary of State level. If I wanted to be able to give away the menu in the cafeteria, the lieutenant in charge of the cafeteria can probably say, yes, you can have it. That's the lines of authority we're talking about here. Now, because of accountability, that guy knows it's all recorded, and he knows he's going to be nailed. And if he has the slightest doubt, he's going to refer it to his boss. So that takes care of the lines of authority. The next tenet is the need to share is overriding the need to know. Some of you may not have realized this transition happened. This transition happened many years ago where most of the generals in the field said, from a tactical situation, it's better that my guys have the information even if it gets into the wrong hands at this particular point. My sharing information is more important than keeping secrets at this particular point. That's in deference to the NSA. You guys have been reading a lot about the NSA. Remember, don't quote DOD, quote me. Okay. Separation of function, that makes the updates easier. So we need to actually, those things that are going to change, needs to be separated and isolated into individual functions. And that makes us be able to do the next iterations and the updates. And as you know, those happen 2 or 3 times a week on your Windows system, right? The 10th tenet, and is the reason I'm willing to talk to you today, and it's because I negotiated this up front, is that these things have to work reliably, even if I tell you how they work. I've got 700,000 people. I need to publish in unclassified, unlimited distribution what I'm doing. That's the only way 700,000 people, when they have to make a decision, are going to make the right decision. That's the only way my suppliers are going to pick up my documentation and provide me products that do what I want to do, because some of the things I'm asking for don't come out of the box. So I've got a contract with the Secretary of the Air Force that I can actually publish all this stuff on the unclassified side in the open literature. And at the end of this talk, I'll give you some guys you can actually quote, some published things that have been approved for public release. And then the last thing is trust but verify. We'll only talk about trust in terms of trust domains when we can actually verify the information that we're provided. We don't do any blanket trusts. We don't do any cross-forest blanket trusts. We don't do any individual blanket trusts. We don't do any process blanket trusts. Okay, out of those tenets leads to a number of primary factors that we have to do as we go through here. If I'm putting a wide-scale enterprise together, I need to worry about naming and identity. Naming needs to be unique over space and time. That means that when I give you a credential that says you are John Smith 12674 is a different entity than John Smith 12673, and there never was a previous John Smith 12674. Okay, unique over space and time. Nobody's going to reuse identities. There's going to be a new identity every time I bring anyone into the system, including servers and services and things like that. So there's no reuse of names and identities. Now, the credential that we're going to use here to provide that is a PKI certificate. How many people are familiar with PKI certificates? 1. Does everybody know what PKI means? How many people know what PKI means? Okay, so let me back up and make this a little more basic then. PKI is public key infrastructure. There's a process that's been put in place where an asymmetric set of encryption involving both a private key and a public key have been devised. The certificate identifies a person and provides the public key. The private key is held by that individual. In an asymmetric encryption, when I encrypt with the public key, only the private key can decrypt it. So if I send you a message that says, "Hi Fred, tell me how your wife is doing," the only guy that can answer that, if I encrypt it in the public key, is the guy with the private key. If he comes back and says, "My wife is doing fine," then I know he had the private key to decrypt that message. That's part of the handshake that we're talking about going on here. So when I exchange certificates with you, I get your public key. If I encrypt something with your public key and you can actually provide the information that I ask for, then that's a holder of key check and I know your identity. And that's how we're going to work from there. Now that certificate has to be issued by a certificate authority. I'll probably refer to that as CA when I get downstream here. The certificate authority is not completely trusted, but he's the issuer of the certificate. He has to maintain a database that says, yes, I issued the certificate to you, because otherwise I could make up my own certificate, right? And it has to be current. That is, the date still has to be good. It has not been revoked. It has not been reported stolen. And I have to check that at that time. So I need to go to that certificate authority, generally through an OCSP responder, which OCSP responder is the particular service that says, yes, this certificate is still valid. If I don't have that, then we have a thing called CRILs, which is our certificate revocation lists, and we have to go look on the list to see if that certificate has been revoked. The date is part of the certificate. The date of expiration is part of the certificate. So we do a bilateral end-to-end authentication. That means I am invoking the U.S. Air Force MyPay system. And the first thing that happens is the U.S. Air Force MyPay system says, send me your certificate. And I say, fine, here's my certificate, send me your certificate. And we make an exchange of messages, okay? And we both satisfy to ourselves that the individual that we are talking to is the individual we expected to talk to at that point. I'll get in a little more. There's more that happens there because we begin encryption and stuff. I'll talk about that a little later. The next is an authorization package. I've got to send you some claims to say I'm not only John Smith, but I am the John Smith who is the commander of Air Wing 6. Okay? And as the commander of Air Wing 6, I'm going to get to look at all the payroll certificates underneath my command, right? If I said to you I was Snuffy Smith, I was an airman, I would only get to look at my payroll stuff, right? Okay, so that's the type of claim I'm going to make on that back end. We use a SAML package for that. Does anybody know what a SAML is? Okay, I see I needed to make this a little more basic. SAML is a security assertion markup language. It's a certificate that gets issued by a trusted STS. We talked about the STS earlier. That's the security token server. It's going to generate this SAML token. And in the SAML token are a number of things that you can do. If any of you knew what a SAML was, you probably saw it at the bottom of your browser a few times. SAML is used for single sign-on when you go to Verizon, for example. If you've got Verizon Fios and you've got Verizon Wireless, those are two different things, right? But you don't have to sign on again because at the bottom, when you ask for wireless information, at the bottom of your browser, you'll see it actually sends a SAML token over, which is a capture of your identity to the Verizon Wireless side so that you don't have to log on again. So in many cases, there's multiple logons that go all the way through the system. If you go to get an airline ticket, it might be the provider of the airline ticket, it might be Travelocity, it might be the airline, it might be the credit card company. All those guys would require you to sign on if you didn't do a single sign-on like that. Now that I've told you about all of that, we don't do single sign-on. It's not very secure. Okay, it's a way to pass identities, though, and that's probably where you saw SAML before. SAML is more capable than just doing an identity transfer. In this particular case, we're going to do credit transfers or claim transfers in the attribute section, and we're not going to do the authentication at all. We're doing the authentication with our PKI certificates. That SAML token I'll show you an example of a little later here as we go through. And then the last issue is, of course, I'm going to have these certificates all over the place. I'm going to have SAML certificates, I'm going to have PKI certificates, and I've got to worry about caches and how long things are and management of that. So those are important aspects of my system as I go through. Okay, so let me fill out my original thing here. It's know your neighbor is the authentication claims is the exchange of PKIs. And you can look at the list of active entities there. They may be a user, web service, web application, aggregation service. Doesn't matter. All of them have to have a certificate. Now this is quite a burden on my DoD PKI SPO, System Program Office, who issues those certificates. He's about to go to panic right now. So I'll tell you a little later, I'm what I call the chaos phase of this thing, which is the stand-up. Every time I go to do something, everybody knows how to do it and tells me that I'm not doing it the right way. So that's the section I'm in right now. I'm no longer in the fine technical stuff where I get to run fun pilots and figure things out. I have to play the politics games. On the authorization claims, you'll see I have that SAML token. That SAML token is fitted into a particular standard representation called a SOAP envelope. I'll let you guys look under OASIS standards to see what SOAP is, but that's a particular packaging that we sew through here. So once I get the authentication through PKI, then I have to send my claims to the provider and say, here are my claims in a SAML token. Now remember, trust but verify. So the SAML token has to be verified through all of the same things that I verified my PKI credential. Is it current? Was it issued by somebody I trust? Did it get to me securely? That means there's a signature on it, and I check the hash to make sure the hash hasn't changed. So what the security token sent me is what I actually received on the signature analysis. Okay, so what is a claim? A claim is a representation of a property in a standard form. In a PKI certificate, that property is an identity, for example. And X.509 is the particular standard representation of that certificate at this point. And then SAML is a standard representation for the security assertion markup language representation. So it has to be from a reliable, trusted source. So in my first case, I've got the DoD PKI SPO. He was stood up just to issue certificates. Each of my users has a smart card. Have you guys seen the smart cards that we use for that? It has a small chip on it. You insert it in the thing. It has your certificate on the chip. It also has your private key on the chip, which you cannot get out of the chip. You have to actually break the chip. You will break the chip trying to get it out, and you still won't be able to get it out. It's tamper-proof. And when I get something in that's encrypted in my public key, I have to actually hand it back to that chip to decrypt it so I can look at it. So by owner of private key, it means I own the chip, right? I'm the one in control of the chip at the time. Okay, verified and validated. I got to have a way to check the source, the dates, what was transmitted to me was what you sent to me, etc. And it can be checked for integrity, yeah. That's the signature part. That's what a SAML token looks like in our context. I've left out, if you go to the standard, there's many more sections of this standard, including an authentication section that is used for that single sign-on token that we talked about. The particular things that we want, we got all this other material here. The particular thing we want is the claims that are down here in the attribute statement right there. Those claims are the sole basis of my access and my privilege as I go through here. Now, that's not what one looks like. That's a tabular representation. This is what one looks like. So those of you that deal with computer science, you realize that sometimes we have to be very verbose to say just a few words of what's going on here. But you'll notice in there's signature blocks, there's dates of expiration, etc. as you go through here. All of the things that are needed to keep this thing secure. The next step in the process is I have to build handlers. Now, most servers know how to do authentication. Most servers are pre-configured as they come. So you might have Microsoft's Server 2000. You might have Linux, Red Hat server. You might have Apache Tomcat. Those guys know how to do authentication back and forth. But my services don't know how to do that, so I have to give them handlers. And I thought originally we were going to specify how to do that, but then I thought I can't say that in enough detail that everybody will do it the same way and not screw it up. So what we're doing is we've actually contracted individual companies to write the handlers on those. The handlers are going to be the front ends of all our services. So the handlers will take those things apart, check the signatures, make the determinations, check the OCSP responders as necessary, and everybody will do them exactly the same way. There's one other reason to put those things in handlers, and that's because when I do certification and accreditation, which those of you that aren't in computer science don't know about, but most systems for security need to be certified and accredited by an individual independent organization. I don't have to recertify those handlers as we go through here. So once I've certified those handlers, then they can inherit that and the next step. Okay, so a new service comes along, they use the same handlers. I inherit that information from the previous certification and accreditation. Now you notice I've got a few other handlers in here that you might want to look at. The SAML validation handler is a big one, but the logging serving handler, we got a very strong logging system here. That's for the accountability, so that we need to hold people accountable for their actions as we go through here. I'll talk a little bit about the standards that are involved in that logging system, but it means we've got to identify all the events and all that. They have to be logged in a standard way. And you see this XML validation handler. The XML validation handler wouldn't apply in the case of HTML for this particular thing, but XML is particularly egregious and very easily abused, and the XML validation handler will check for abuses of the XML as we go through here. Okay, I think I just told you about the advantages of using these handlers. This is an access control list. It's the type of access control list that you'd see on an application that you might have on your computer. For example, who can access it and under what circumstances, and who can't access it. So we got two different sections here, things that allow access and things that deny access as we go through here. That's a standard representation in the current form. So my pay example would have a table like that that says, if you are an Air Force airman, you can access, okay? And then it leaves it up to the service to decide what level of access you get. The Commander Air Wing 6, you can access. It leaves it up to the service to decide that the Commander Air Wing 6 can look at the people that work for him in the Air Wing. The claims that deny access might be something that's currently in your portfolio that keeps you from getting there for one reason or another. That's not what we use. That's the way it's currently done. What we do is a formally defined access control, and this is XML-like. I actually have an XML version of it, but it's much harder to read, where the owner of the data specifies the particular claims and how you compute those particular claims that it's going to entertain for access control and for privilege. I don't want to go through all of this right now, but you can see in here the definitions of a wing commander, for example. This is a particular example from a defense readiness system where we're trying to figure out where guys are ready to deploy or not for overseas. So example, if I want to send a guy to Italy, he's got to get shots for various things and stuff like that, so I check his shot record. I got to check his training record and see if he's actually had basic Italian. I don't think that's a requirement for deploy to Italy, but it might be. So all of these things are specified in here by the owner of the data. We have an enterprise attribute store. We do not have accounts in this particular system. Each individual in the system is registered as to where he works, what his job is, what his characteristics are. Those attributes are imported from a multitude of back-end systems called enterprise systems such as MIL-PDS and DMDC. MIL-PDS is the HR system, the human resources system for the Air Force. And that data is stored away, and we'll use that to actually compute claims. So you see this computation of claims on here that is converted to, now there's a couple of acronyms on here you don't know about. PBAC is policy-based access control. UBAC is use case-based access control. The nice thing about claims is it folds all that together. So all of those access control systems that you may have seen, those of you that know anything about computer science, a lot of times we allow guys to use a service because of his role, for example. That might be role-based access control, right? Or the fact that he has a PhD, which would be an attribute-based, right? My attribute is I have a PhD. And some of it might be identity-based. You know, if your name is Smith, I'm going to let you do it, okay? That's identity-based access control. So you see all these things with BAC on the back end. One is policy-based, attribute-based. The nice thing about claims is they all fold in, right? Any of those things that you want to builds into that claim that has been specified by the data owner. So pick your favorite. Now, the real ecosystem looks like this. That was built by Accenture, and Accenture has actually run tests on how many claims we can do. I've got some data in here later about how we can do that, how rapidly we can do those types of claims. The real problem that everybody faced at this point was, okay, now I'm doing claims where I used to just do single parameter type stuff. How quickly can you do that and how fast is it? You see a number of different representations here that lead to the claims repository, and the claims repository is the thing that hooks up to the security token server that builds a SAML token that sends the SAML token to the service that you're trying to access at this particular time. Interesting problem, unique, probably not to military systems, but I said before my 4-star needs response in 10 seconds. And so I've got to be able to maintain a standard of quality that says 10 seconds. Most of my 4-stars don't actually sit down and touch the keyboard. 4-star is a 4-star general, so I have to be careful what I say here and make sure everybody understands what I'm talking about. A 4-star general will turn around to his colonel, who is his adjutant, that's his secretary, and say, go get me this data, right? Well, the 4-star general wants it in 10 seconds, so the colonel has to be able to get it in 10 seconds. So my quality of service is based on a 4-star general and whoever he says is going to do it. Now, the interesting thing is the 4-star general might be the only guy that's entitled to that information. His colonel may not be because of his role in the organization and his attributes and stuff like that. So I had to build a delegation system that allowed the owner of a particular claim to be able to delegate that claim to someone who's going to do the work for him. The developer of the data has to actually approve that. So the owner of the data will say, this is only for 4-star generals, and by God, you're going to sit down at the keyboard. Now, when the 4-star general calls him on the phone, they usually back off and they say, no, sir, you can give it to your colonel. Yes, sir. Okay, that's the way it normally goes. So I had to build a system by which the general could say, I give this to my colonel, and this is the delegation system. And you see we have a delegation service here. The general is the one that has to actually do this because he owns the rights to be able to give that claim away. And we have to make sure that when he gives that claim away, he hasn't violated anything of the data owner or anything in the system itself. For example, I cannot give secret data to a guy that doesn't have a secret clearance. Okay, so that claims delegator is a very complicated piece of software that has to check a lot of things before it allows that claim to be built that says that the colonel can actually retrieve the information for the general. One of those political things that we talked about. This is a security token server. It actually has 3 interfaces. It wouldn't have to have 3 interfaces except that people are different than machines. I wish you guys would straighten up. We actually tried to fix the browser. I couldn't sell them on that. We actually put an add-on to the browser that would allow the browser to talk XML and still bring it back to HTML to the browser for rendering. But somehow it looked like another server that was being put on the desktop, and that made everybody panic when I said I was putting a server on the desktop. So we didn't quite get that through. So there's 3 interfaces here. There's an interface for people, there's an interface for non-people, and there's an interface for administrators. Even the administrators have to do a full PKI bilateral authentication to administer the system. No username passwords anywhere in this system. So all of the work you're doing on computers right now is probably all based on username passwords. You won't be able to do any of that in the U.S. Air Force. Okay? So here's what a full-blown architecture looks like in a normal circumstance. I have my user sitting down here at a web browser, and he may not be sitting at that web browser inside the enterprise. In fact, with my CAC card, my smart card that I plug into my thing, the first thing I do is I validate myself to the enterprise, and I set up a virtual private network. So this could be happening from wherever at this particular point. But logically, from a standpoint of the enterprise, it looks as though the user is sitting within my high assurance enterprise at this point. At some point, you actually have to trust a user. I know we don't want to do that too much, but if he's sitting in a coffee shop, I want to be sure that nobody's sitting behind him reading his screen, right? The first thing he does is he doesn't go to the service. He goes to the security token server, and he tells the security token server, I want to access this service. That's because in our rules for accountability, the only security token that can be retrieved by the security token server is the one that requests the security token. So the user has to go request a security token, and on the way he has to bilaterally authenticate with his PKI credentials as we go through here. The security token server will then post back that SAML token through the browser to the service. And of course, the initiation of that starts a bilateral authentication to the service. Now, why would I go to the trouble to post that back through the browser? Why wouldn't I just give the guy a SAML token to hold? The number one vulnerability in all of this is the browser. The most vulnerable piece of software you have on your computer well, I don't know, if you have Google Mail, maybe it's Mail, but if you don't have Google Mail, it's the browser. The browser has the largest number of vulnerabilities in it, and I don't want anything held on that laptop or that workstation that doesn't need to be held there, especially something like a SAML token that could be picked up and used again. Although that SAML token is going to expire, and it's going to expire fairly fast for a person, we've got a 5-minute time limit on that SAML. So if we can't get this session established in 5 minutes, we have to start over again. Remember, my 4-star wants 10 seconds. So 5 minutes is like an eternity. Okay, that gets posted to the service. The service actually does the bilateral authentication and says, yes, okay, I know who you are. The next step is, let me look at your SAML and see if I even want to talk to you. The handler does that. And once he says, yes, I'd like to talk to you, he says, okay, let me calculate what kind of level of privilege you get here based on your claims, okay? And then he may actually try to execute something. Now, WASP is the Web Application Service Protocol, okay? In doing so, he may actually go off and request information from other services. You'll notice it's symmetric because this particular guy has to go request a SAML token to go call another service. So I do let him cache it because he's in the computing center and he's not running a web browser. So I will let him go get a SAML token and hold it for a while so that I can communicate with these guys without having to go that every time. But I still have to do that round trip and so forth. Eventually I may have to go outside the system and get something. Outside the system implies an applique legacy system that's going to worry about sanitization, all my deep packet inspections and things like that. So anytime I go out the system, I've got this wrapper guy here who's going to take care of all that stuff. This is a new paradigm because most of those things, every one of them gets saturated as we go through. The next thing I said, it's had to work for my MOD partners and my Afghan security group that I wanted to trust with data. It starts with a federation agreement. It used to start with a handshake in the field. And maybe I'll give you my CAC card that you can use when you want to use it. Now it starts with a federation agreement. So we start with a federation agreement. This is the preamble. But you notice in this particular federation agreement, it not only says what we're going to share and how we're going to share it, it says what machines we're going to use for credentials and which ones we're going to honor and which ones we won't. And if you don't bring me the right credentials from the right machines, I'm not going to honor that. So I might take an MOD PKI certificate. I might actually put that certificate authority in my trust store. I'm going to have to be able to verify and validate it though, okay? Which means I may have to go to London to check on a server in London to see if your certificate is still recorded in London. So that's a part of the federation agreement. But once that's done, it works exactly the same way as if the guy was a member of the Air Force. There may be a necessary conversion. So I said my naming need to be unique in space and time. I may have a collision with the MOD naming, for example. We use distinguished names from the certificate. They may have a different way of naming things, and I may wind up with collisions. So I may have to map that. So the first thing I do when I come in, I recognize a federation partner. I may have to map that into another name. I may have to map his credentials. And in many cases, I might want to map his credentials for access. For example, I may have an agreement that says if you bring to me a SAML token that says blue, green, orange, I will convert that to wing commander of the 6th Air Force or something, so you can look at that data. So I might not want to actually give away the information by which I actually give access. I may want to say you bring me certain characteristics, certain tokens, and I will convert those into the ones I actually use as I go through here. So that's a federated conversion on the SAML, and then we issue a new SAML as we go through. So here's the federation thing. I have a federation member. Am I keeping you guys after? Remember we talked about before that federation can either be somebody sitting at a web browser, or it could be an application of some kind actually proceeding to query this particular thing. When it gets to the handlers, it's going to say, I don't recognize the signature of this STS. And the first thing it does is it goes to the federation server and says, do I have a federation partner that meets this requirement here? And it goes to that federation list and it says, okay, do I need to remap anything? It says, no, I don't need to remap anything at this point, or maybe I do. I remap it, I reissue the SAML token and send it back. Now everything works just like before, because now I have a SAML token that's recognized, verifiable, and reproducible at this point. So the entire rest of the thing works just as normal. So it's fully extensible. Let me talk a little bit about cryptography. When I actually launch on these services, the Air Force is worldwide. I may have to go halfway around the world to get information. I may go through a server in Beijing. Every single message is encrypted. The bilateral authentication can be linked to transport layer security representation. Most of you in your browser will see a little lockbox at the bottom of the browser, and that stands for SSL. What you don't know is SSL has been broken. So if somebody really wants to get your information from one of those standard little lockboxes at the bottom and it's SSL, they can actually do it. The broken means that people have figured out to hack into your system and figure out what the SSL cryptology is doing to it. We use TLS 1.2, Transport Layer Security. It's a follow-on to SSL, and so far it hasn't been broken. So when we talk about cryptology, we talk about various things. There's an algorithm for encryption. That's a mathematical equation. There's a cipher that says this is the computer program by which I'm actually implementing that algorithm. It will also do other things like break it up into message bytes for FTP and things like that. It will put trailers and headers so that somebody can put a message that's been broken into several little short messages back together again on the other end and stuff like that. That's called a cipher. Okay. Now, any cipher, I won't say any cipher, most ciphers can be used for more than one cryptographic formula. The formula that we're using right now is the AES 256. If you don't know what that means, you can look it up with Google. It's an open standard. But the cipher that we use is TLS 1.2. And everything is encrypted. So I've got a little note here that says that the private key lives in that HSM. And remember, that's on your card if you're a person. That's a piece of hardware. The public key, you might as well post it on a bulletin board. There isn't really a bulletin board, but it's open to everyone. Anybody can go look up your public key at this particular point. So the public-private keys are used in authentication. During that process, we exchange material for computing a key, symmetric key for the TLS encryption of the message itself. So both sides will compute the same key, and the communication will be from point A to point B. Nobody in between should be able to read it. It's targeted for the target as we go through here. That's all I want to say about that at this point. If you got some questions about cryptography, let me know. Been asked several questions today about cloud-based. Cloud-based scares the hell out of me. There's a number of things going on in the cloud that we have to worry about security. First of all, our accountability paradigm goes to hell in a handbasket when we start spinning up virtual instances of things without unique identities and things like that. This little diagram kind of shows how we prefer to do it. We prefer to repost it to virtual systems that have identities assigned to them and credentials that are linked to our enterprise attribute store. So far, I haven't been able to get anybody to actually stand one up this way. And so we have been telling people we're only going to go in a private cloud. For those of you that don't know, a private cloud is a computing center. Okay, a public cloud just means other people can get access to it. So if I go into a DISA-DEC, DISA is Defense Information System Agency, and they have computing centers. If I go into a DISA-DEC and I own that DISA-DEC, that's fine. That's a private cloud. I'll do a private cloud. I will not do a public cloud or a multi-tenant cloud at this time because I haven't been able to get the developers of the cloud to be able to do this type of arrangement that we show here. I show a number of security issues as we go through here. People watching stuff in transit. The actual storage may have some nefarious material in it and stuff like that. You have to be careful about how you store those things that you build back into virtual images as we go through here. Okay, so this is a solution that we prefer as we go through here, and I just kind of talk through it. The things in red are the things that we need to add. So far, trust me, I haven't been able to get anybody to do it. So far, clouds are not usable except private clouds in the Air Force system. I won't go through those remarks. Records. We talked about records as we go through here. And we have written specific forms of recordations for forensics and accountability as we go through here. So when we see NEFRS behavior, we have to be able to pull all the log records. In fact, what you see here is a representation of some of the records that we do, but I'll show you on the next slide the number of standards that it takes to actually do that. First of all, there needs to be a standard header for all events, including sequence numbering that goes with the thread and the session count so that I can pull the string when I go to the database. I can pull the string on all the session events that go with that, and I can restrict myself to just look at those, because remember, it's a tremendous volume of data here. The second is an event enumeration. I need to have all of the events enumerated, the standard events that will happen and require the logging. Now remember, I've got a logging handler, so all we have to do is package this up and hand it to the logging handler, and it'll do it in a standard form. And of course, that's the standard form on the side here. So in order to get that logging system straight, I have to have 3 different standards as we go through. I've written standards, but I haven't been able to get a standards body to pick up those standards yet. The next step, of course, is I've got to be able to upload that to a knowledge base so that it's available. The knowledge base we anticipate is one that will also handle the help desk functions as we go through here. So it'll be able, the help desk guy will be able to look at the logs of your particular encounter. It'll also be able to pull up the manuals and things like that as we go through here. So the real question is, how do I get it to that database? I have another ecosystem that actually retrieves log records and uploads them to the database. And I'm not going to go through the details of it right now. It's an agent-based system. It will periodically or on demand go through and pull the logs. And in many cases, if it's COTS, I don't have it in my standard form, I may have to mediate it and put it in my standard form before I upload it to the central database. So each one of those agents is a mediator as well as a cleanup as we go through here. I talked about some of the standards that we got here. I won't talk about them now. Let me give you a little bit of the history. 2004, 2006 is before I got involved with this program. 2006 is about when I came in. But we were at the what they call stovepipe consolidation. Some of you heard the stovepipe before, and if you think of the chimneys that you have at power plants and stuff like that, those are the stovepipes they're talking about. They were all on the same building, but they were kind of separated, and you had to go back to base in order to communicate across them and stuff like that. That's called a stovepipe system. PKI improvements and integration with MS Windows and so forth. Active Directory consolidation, 124 down to 2. Those of you that know MS architecture realize that's a big deal. Seamless AD account migration. Air Force Portal PKI integration and web service integration happened. And we're starting the investigation of airborne and space systems at that point for integration into the enterprise. When I got involved in 2006, we were looking at multiple enterprise cross-domain, multi-level security solution. I've got some papers in the back listed here you guys can read and quote. These are all the things we just talked about, where we started to do this innovation with pilots and things as we went through. 2009 to present, this is the chaos section at this point. We've won our battle about the pilots. We've been able to show that we can do these things. I've got some numbers on here in terms of the computation of claims tokens and the generation of SAML tokens in terms of quality of service. These are actual measured events. I've got an asterisk down here on JIE. JIE came in last year and said, okay, we want to make this a DoD enterprise. They didn't mean they wanted to make my Air Force a DoD enterprise. They meant they wanted DoD to be an enterprise. There's an organization called DISA, Defense Information Systems Administration, who thinks they own the computing space. And so they began to put things together. We began to have arguments with them. We began to have debates. And They're going down their way, selling their products. I'm going to have it up and running before JIE hits their first milestone and fails, so I will have it in place at that point. Here's my headache, governance. Everybody and his brother is looking at it now, so I write a piece of requirements. It goes to a board of 3 stars and 4 stars who have all their own subject matter experts who go review things. It goes to this entire system to get there. You can imagine what a nightmare that is as we go through it. So basically, I'm out of the fun stuff. The fun stuff is coming here talking to you about it, right? And I'm into the administrative BS as we go through it. I've kind of listed in here, I'm going to leave these slides with you. I've listed a number of open source references that you can get. Remember, I negotiated up front that this is going to be open source. And most of this information is in whatever level of detail you want to consume it. I have many, many backup slides. You're free to ask any questions you want at this point. Or if I put you to sleep, surely somebody has a question. Yes, sir?
I'm assuming that a lot of the chaos probably comes from the integration of the new system and trying to phase out the old system. So how is it that, from the user side, is it a long learner to learn to use the new system, or is it something relatively intuitive?
Okay, so the question is about the chaos and whether or not it has an impact on the user. The answer is no. So we have a couple of services that we actually paid to stand up in the high assurance system. We have a mandate that goes down that says next time you do a major integration, they put a dollar value on it, you have to bring it into compliance with what we call ELS, enterprise level security. And we're getting a lot of security questions from those guys that have to actually stand it up. All of those guys know how to do this. They just don't know how we do it. Okay, so they all know, if you've been to a computing center, it's kind of interesting. You may see a stack of what they call appliances sitting there. And when something comes in, it goes to the Aruba stack and it looks for dirty words. And it goes to the next guy in the stack and it looks for signatures of malware. And it goes to the next guy in the stack and it might look for malformed addresses that might indicate, and so on. And there's a big stack of these things as you go through. They have mixed all of the high assurance and low assurance stuff together. So they don't know what kind of nonsense they're getting from the www when they get in there. So we have these arguments with them that say, no, I've got communication going on between a vetted user and a vetted machine that you have on your end. Why am I doing all this? Nobody can give me a good answer except I always do. That's what I do. I know how to do it, and stuff like that. So I get a lot of that stuff that people say, I know how to do it, and it's not your way. So, but the user, on the other hand, should be blind to this. So in terms of the user experience, I should actually give him a better user experience that's more secure, okay? But it should look the same to him as he goes to check his MyPay or he wants to get the tactical picture in Kabul or whatever. Should look the same. Yes, ma'am?
You've talked a lot about SOAP and SAML and SAML. Have you considered working with REST?
Okay, so the question is about using the OASIS standards, SOAP, XML, SAML, versus REST. I know many applications now use REST interfaces. The difficulty with the REST interface is that the standard is too flexible. People can misconfigure and at a low level of security the REST interfaces, and until somebody actually puts a profile in place that secures those interfaces so that they are proper, we will not consider them. We've passed that information along to the standards writers at IETF. IETF is the one that does. So OASIS does the standards we talked about in the first instance. SOAP, XML, SAML, those are all OASIS standards. We don't use all of them. We use specific parts of them. The REST standard is not securable by itself. You can do things securely with REST, but the standard itself doesn't force you to do them securely because it has too many flexibility points. So we are excluding REST at this point until such time as we get a profile that actually makes it difficult for you to write an insecure REST interface. Yes, sir.
Is your PKI infrastructure still ISA based?
The PKI structure is based on X.509 interface, which is an IETF standard. There's a system program office stood up by the DoD for issuance of those certificates. DoD has mandated, by the way, that everybody should go to PKI enabled on their thing. They haven't quite worked out the NPE stuff, the non-person entity stuff that we talked about before. So it's an X.509 certificate. It's the way we generate the keys is the keys are generated in the hardware module. The public key is exported. We then make a request to the DoD PKI for the certificate that goes with it. And then the certificate is installed on the server or the service in this particular case.
And who is the authority?
The certificate authority is DoD
DoD
PKI SPO, yeah, System Program Office. That's our #1 certificate authority. There are others that we will be forced to recognize, and I see it coming. For example, the Veterans Administration is one. There are commercial entities that actually do certificates that claim to get close to the same level of scrutiny that DoD doesn't, but for example, Verizon, for example, can actually issue smart cards and claim to be PK509, but we're still arguing over those others. I don't know what I can do about the VA. I think I'll have to accept the VA as a certificate authority. But we want to keep that root store as short as possible, that trusted certificate authority root stores as much as possible. Also, we want to make sure that the full cycle on those guys match the certificate authority, which is a check that the servers don't do right now. So if it's a DoD, if it says I've got a DoD issued name and I'm on a VA certificate, I will reject that. So I will take a VA certificate on a VA certificate authority. And if I get a DoD certificate that says it's VA issued, I'll reject that too. But I make that check in my handler, by the way. Make no mistake, that check is not made by the authentication handlers that you have on servers now. Next question.
I'll ask a question.
Oh, okay, good.
So you have a lot of this. I'm not a security expert. I'm not even a computer science person. I'm electrical engineering. But there's obviously it's a very hot topic, security, and you have a lot of people working in the government domain, and then there's a lot of people working in private industry. I suppose places like Google are working on their own level of security. What do you see going forward in the future? Will this be driven more from the government side, or will each company sort of evolve their own security system, or will it evolve into one standard, and where will that come from?
It will not evolve into one standard because of markets. So there are different concerns. The defense industries have different concerns than the Googles of the world. The privacy and sharing information is different among those. There is a subclass of people who are interested in the higher level of assurance that we have. The banks, for example. The banks are getting waxed. I don't know if you guys have been following the news lately, but the banks are getting waxed pretty good about fake accounts and things like that. They're ready to come into a higher assurance enclave. So we may be able to export some of this stuff and increase the market share. The real problem we have with the DoD is the DoD used to be the market share. They used to be 90% of the market 20 years ago. Right now, they're a very small part of the market share. The Fortune 500 companies probably are 5 to 10 times alone what DoD is at this point. And the rest of the market is another 20 or 30 times what the DoD market is. So the power I have when I go talk to Microsoft, I'm going to talk to Microsoft tomorrow, by the way, about some of these things. The power that I have when I talk to Microsoft is much diminished because I'm not the big boy on the block anymore. The Fortune 500 outweigh me by quite a bit, and then all these other ancillary things outweigh me by even more. So unless we're willing to bite the bullet and stay with this, or we get a consortium, and that's my next move is to try and get a consortium of people that are worried about high assurance to increase the market share of people that are worried about these things. DoD is obviously worried about it, but at most I'm going to have 6 million users in DoD. And I've got to get to the 30 or 40 million level before Microsoft is going to want to talk about modifying their software. So it's a problem. It's a problem.
Gotcha. So we have one more question, and we'll wrap it up.
So you were talking about how users only have one username, or so is that tied to the certificate? So
yes, it's the identity. So they only have one identity in my system, the high assurance system. I know you have 17 emails, and I do too. So we all have identities that we use for different things throughout the system. But in the high assurance system, I only have one identity, and it's forever. So if you change identities, that old identity goes away. There's no simultaneous usage of two identities in this system. Now, I'll make an exception for the classified side because I might have a separate identity for the classified side than I have for the unclassified side. And the way classified side works right now, I may have multiple identities because those enclaves are actually multiple. But within each one of those enclaves, we only have one identity. It's unique over space and time.
what happens if one is compromised, though?
That's a good point. So here's what happens is the people who own a CAT card, for example, somebody steals a CAT card, they have to have a passcode to use the CAT card. We're working on some biometrics to go with that as a secondary point of authentication. When they first log in and get the VPN set up, they put in their passcode. It sets up a Kerberos link to the AD and brings them into the environment with the VPN. If that card is compromised or it's stolen, the user's supposed to report it. Now, you say, okay, they shot the guy and threw him in the ocean, so I don't know about it right away, right? There's an expiration date on all of those CAT cards. How long you tolerate that is a different question. So we do behavioral monitoring to see if this guy who's supposed to be on an extended vacation is doing things he shouldn't be doing. Okay, that's the monitoring we just talked about. That will dispense forensics teams to find him and see if his CAT card's intact. If he reports his CAT card stolen, it gets on the expired list, and it will no longer validate when it goes back to the OCSP responder. If he doesn't have it for a long enough period, it expires, and he will no longer be able to do it. But he can only access the things that he has claims for. So the things that are compromised are the things he has claim for. And remember, the person who stole the CAT card needs to have his passcode, and at some future point here, he'll also have to have one of his biomarkers so that we can doubly authenticate that. If that uses it, then he gets issued a new name. He becomes a new identity. His old identity is never reused, okay? And that happens even if a guy changes. For example, an individual may change, retire from the Air Force, and get onto a defense contractor and may be issued a CAT card on a defense contractor. Right now, they allow him to have those two CAT cards. In the new system, he will only have one. That one will be differentiated by what's called a persona code. The persona code will say whether or not I'm using my reserve capacity or I'm using my contractor capacity or whatever. But you only have one CAT card, one identity, and the persona code will tell you which role he's acting in. Okay, and that's coming. That hasn't happened yet, but it's there. So as many as 4 CAT cards right now can be owned by one individual in the services. We're getting rid of that. And again, that's another point of contention because there's a lot of rice bowls that you got to fight with.
All right, let's thank our speaker one more time.